And then one last final review of some algebraic ideas that will help us not only verify and prove and simplify identities and expressions, but will help us actually solve equations later on. What we're going to do is review factoring real quick. You've already seen me use it a couple of times. And let's just remember what it meant for a polynomial. When I gave you a polynomial, like let's say x squared minus 2x minus 8, the idea was to figure out what times what can I use to create that monomial, or excuse me, that trinomial. And usually what we use is what's called guessing and checking. Some people use the AC method, but the guess, I'll look at my first term, x squared, well that's x and an x. Look at my last term, negative 8, well I'm looking at plus 4 and minus 2. So what I've given myself in terms of the FOIL process is I've looked at the F and the L to give me a guess. To check, I'll use the O and the I. So in this case, my outer is a negative 2x, my inner is a positive 4x, and that gives me a positive 2x. So I'm a little bit off. So this would factor as x minus 4, x plus 2 after my second guess. But overall what it means is to multiply something, this binomial times this binomial is this trinomial. And we're going to do the same thing with trigonometric expressions. Another classic case is what we call the difference of squares. A squared minus b squared. When I have this form, it factors as a minus b, a plus b. Right, so that's a classic situation. So we're going to basically see the same thing, but rather than x's and a's and b's, we're going to have cosecant squareds and secant squareds and cosine squareds and cosines, but we're still going to factor. And so in this first one, what I see as an opportunity, I see a difference of squares. 16 is 4 squared, and obviously this first one is cosecant squared, and we're subtracting them. So following this difference of squares pattern, this factors as cosecant of x minus 4, cosecant of x plus 4. And so there would be the factorization of that particular binomial, if you would. What's cool about this, like I always told my students for factoring, is you can check your work, right? Refoil this out and it should give you what you have back. And same thing here. Here what I see is a trinomial in terms of secant. So what two things multiply up to secant squared? Well, that'd be secant x and secant of x. What two things multiply up to negative 8? Well, we've kind of seen that. Why don't we try minus 4 and plus 2? And if we did the outer and the inner, we get a negative 4 secant of x. The outer is a positive 2 secant of x, giving us the negative 2 secant of x that I want. So there's the factorization of that trinomial. All right, and then in terms of cosine, again, we see a cosine squared and a cosine. So what two things multiply up to 2 cosine squared? Well, I know for sure 2 cosine theta times another cosine theta. What multiplies up to negative 3? Well, lots of combinations here. How about I try minus 3 and plus 1? So to check it, when I do my outer, I get a 2 cosine theta. When I do my inner, I get a negative 3 cosine theta. And combining those, I get a negative cosine theta, which is exactly what I need in the middle. So there is the factorization of that trinomial right there. All right, so nice review of factoring. Again, it's going to probably play a role at times when we do prove or simplify or rewrite expressions, maybe just factoring something, and then what usually happens is things will cancel out and things are nice and neat. We can get rid of quotients and all that fun stuff. But let's go ahead and go back to our verification and proving just to kind of see all this algebra in play, right? Performing operations and simplifying, factoring and simplifying, right? Let's go see how that helps us out in a lot of different situations. See you guys in a moment.